This video presents an agent-based model for phenotypic prediction using genomic and environmental data. It demonstrates how an adaptive, cooperative multi-agent system is able to make a prediction of phenotypic values knowing genetic and environmental parameters. First, you will be introduced to how the system was built. Then, you will be shown a sample of results where the system cooperatively converged to a solution. Finally, you will see that the system can adapt itself to a human user's intervention. As described in the paper, the system contains two kinds of agents, the constraint agents and the problem agent. The problem agent gives the constraint agents directions about the actions to do in order to make the solution more satisfactory. The constraint agents aggregate the constraints they are responsible with to provide a set of data to the problem agent. The problem agent can then evaluate the solution provided by this set of data and provide directions to the constraint agent for the next iteration. Let us see it working. The problem is a leave one out test. We are trying to reach a value of 244, the real value of this example. A prediction is represented like a histogram. The horizontal axis represents the value predicted by the dataset, and the vertical axis an arbitrary scale of the trust given to each predicted value. The evolution of the predicted value follows. On this result returned to the user, the green line represents the real value we were trying to predict. As an example, here is the evolution of the tightness of one of the constraints. 1 means a fully released constraint, and 0 a strictly enforced constraint. To illustrate the adaptivity of the MS, the same problem will be used. We use a graphical user interface which enables the user to interactively add, modify, or remove constraints. At this point, one of the constraints is forcefully tightened. The system adapted itself to this change. Now, let us remove another constraint. You will see that the predicted data becomes suddenly less precise, but that the system adapted itself to keep a good quality on the predicted values. This is the end of our video demonstration. Live demonstrations will be possible at the conference. Thank you for your attention.